In this video, I'd like to discuss the use of solenoids with the microbit. A solenoid such as this one has two different positions. It has its outward position, which is maintained by the spring out here in the front, and then you have the inward position, which is where the spring is compressed backwards. If I leave it go, you can see it returns to its initial position. Now, for this solenoid to work when needed, we work it in conjunction with a microcontroller such as the microbit here. Now, you can actually use the solenoid itself directly from the microbit or from the breakout board itself using the 3 volts and ground. The only problem there is that it stays in one position. So for instance, if we have it to the ground at 3 volts, either from the microbit or from the breakout board, it will be in the inward position like so, and it will be held there. Now, what we want to do is we want it to move in and out when we want it. So we're going to use a relay. And now what the relay will do will basically act like a switch. When a signal is sent from the microbit, it will either turn on or off the actual solenoid itself. So it'll either be in the outer position or it'll be the in position, depending on if the signal is high or if the signal is low coming from the microbit itself. So to do this, what we're going to do is we're going to put together this bit of a diagram here. What we have is our normal 9 volts, which are going to our Keytronic all-in-one breakout board, which can take up to 10.8 volts. This board will supply 3.3 volts to the microbit itself, and it also gives the functionality of all the additional pins as well as some other connections down here. For this, all we're going to be using is our ground pin, our 3 volt, and one of our signal pins. Okay. Now, technically, this circuit itself can work just on the microbit itself. You don't actually need the Keytronic all-in-one breakout board. You can see that you have your pin 0 or pin O, whatever you'd like to call it, is going back to the signal pin of the relay. And then we have the VCC, which is going to be our plus 3 volts. And then we have our ground, which is going back to our ground. Now, the relay itself then has its own battery. So I've just put a 3 volt here because this is actually a 4 volt solenoid, which we're going to be using. You're going to have the positive going to the center pin, and then you're either going to have the plus going back to either the left or right hand side of that center pin. That's for normally closed or normally open, depending on the state you want your solenoid to be in consistently. The way that I've it set up here, the solenoid is always reaching outwards, and then when it is given a signal, it clinches inwards. Okay, so let's put this together. Okay, so now that we have the circuit put together, you can see we have our 9 volt battery going to our breakout board itself. We have the 3 volt, we have the ground, and we have signal pin 0 or O, depending on what you want to call it. And then we've coming back to our relay. On this relay, the signal pin is all the ways over on this side. The plus is in the center and the ground is in the far side. That is usually marked with a letter on the actual relay itself. And then we have our 3 pins. The center pin is going directly back to the solenoid, and then the outer pin is going back to the battery, and which goes then back to the solenoid as well. Okay, so now let's jump over to our microbit code editor, put together a small bit of code so that we can open and close the microbit using the microbit and the 2 buttons on the front face. Okay, so now that we moved over to the microbit code editor, what we can do is start off by deleting our forever and our on start block, which you can see I've already done. And then what you're going to do is you're going to go for an input. Now, the inputs we want to use to control the solenoid are going to be the 2 buttons on the microbit itself, which is button A and button B, as you can see here. So let's bring out button A, and we'll duplicate that by right-clicking on it and duplicating it, and changing the second one to B. Now, we also want to use our pin 0 or pin O, which we're using to send the signal. The signal we're going to be sending will be a digital signal, so we're either going to have a 1 or a 0. So if we go down here and go to pins, and we go to digital right pin 0, and we can actually duplicate that and bring it over here as well. Now, it's already on pin 0, pin O, so we're going to keep that. And then we're going to change the first one to value 1, and we're going to leave the second one at value 0. Now, this is all the code that you need. all we need to do is send pin O to a high or a low, so 1 or 0, and that will then activate and deactivate the solenoid. Okay, so now that we've uploaded the code to the microbit itself, we can turn on the power. You'll see that the light will come on the breakout board. And now let's test it out. We'll try button B first of all. We'll try button A. Okay, we can see it's in the backward state. Now we go B again. You can see that it's forward, compressed, forward, compressed. Bring that up a bit closer. Like so. And that is how you use a solenoid with the microbit.